Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker. Chapter 15, part 2, Latin squares design. So what we're doing here is an example where we have the response being the reduction in nitrous oxide. The treatment is 4 different types of gasoline additives. And the blocking variable 1 is the type of car that's being driven. And the blocking variable 2 is the driver. So in this case, we notice that for each of the 4 drivers, the treatment shows up 1 time, A, B, C, D, A, B, C, D, A, B, C, D, and A, B, C, D. And then if we look at the column, same thing, A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. All right, we have the driver means and the car means as well as the treatment means. So for the mean of 18, it's really if we look at 21, 20, 15, and 16, and if we average those equal 18. All right, so if we write out the model, remember we have Yijk hat is equal to mu hat plus beta hat I plus gamma hat J plus tau hat K, right? And what we can do is we can estimate the slope coefficients. Remember that mu hat is our intercept, so we can estimate our slope coefficients using the formulas that we have here, these 3 formulas. Okay, so our tau hat 1 is equal to -2, tau hat 2 is 2, tau hat 3 is 1, tau hat 4 is -1. Beta hat 1 is 3. Beta hat 2 is -5. Beta hat 3 is, beta hat 2 is 4. Beta hat 3 is -5. And beta hat 4 is -2. And when we get the gamma hat 1 is -1, gamma hat 2 is 0, gamma hat 3 is -1, and gamma hat 4 is 2. Okay. Excuse me. So if we look at this code here, we've created a data set that has the driver, the car, the treatment, and the emissions. So instead of A, B, C, D for the treatments, I just use numbers 1, 2, 3, 4. Shouldn't change the output. And we have each of the emissions going through. And what I did here is I used the tapply function to get the row means. And then I'm using emissions indexed on driver. And I'm asking it for the mean. I did the same thing to get the column means using the tapply function. Data $ emissions indexed by car. The function is the mean. And then for the y bar ... k's, I'm taking the tapply function, applying it to the emissions, indexing by the treatment, and asking for the mean. And from there, I can get each of the pieces, right? The y bar ... that's the mean of all the data $ emissions. So our y bar ... is just 20. All right. If we come over and we look at the linear regression model, we can use the ln function where we say y follows factor treatment plus factor driver plus factor car. We identify our data set to be called data. And then we ask for the summary of our Latin squares model. And what we end up getting is this linear regression model. Here's all of the estimates, right? And if we write this out, what this is saying is that we have y hat ijk is equal to 20, right? 20 plus 4 times the indicator variable for treatment 2, plus 3 if you are in treatment 3, plus 4, plus 1 times treatment 4, plus 1 times driver 2, minus 8 driver 3, minus 5 driver 4, plus 1 times car 2, plus lots of zeros, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times car 3, right? Plus 3 times car 4. So let's just do a spot check for driver 2, car 4, treatment 1. Okay, so let's find out what y hat. We said driver 2, car 4, treatment 1, y hat 2, 4, 1. Let's use both of these equations to make sure that we can get it. So our mu hat, that was 20, right? So 20 plus our driver is our beta hat. So what is our beta hat 2? Beta hat 2 is 4, right? And then car 4, remember those are our gammas. So plus 2, and then treatment 1, so that's tau hat 1 minus 2. So our estimate here would be 24. Okay, now let's use this regression equation that we have up here. Y hat 2, 4, 1 is equal to 20. We said treatment 1. So that means treatment 2 equals 0, treatment 3 equals 0, treatment 4 equals 0. We had said driver 2, so we say plus 1 times 1 is 1. And then we said car 4, right? So plus 3 times 1. And if we double check, regardless if we use this model parameterization that we have up here, or what was output from our prediction for y hat 2, 4, 1 is exactly the same, and it better be. So, but we're happy that it didn't matter which one we used. Okay, for our ANOVA table, remember, we're going to have the source being due to treatment, blocking factor for driver, blocking factor for car, error, and total, right? Our degrees of freedom, right, are going to be t minus 1 for each of these. So there's 4 treatments. That means the degrees of freedom are 3 for each of those. And then our residual degrees of freedom should be 6, because all of those have to add up to 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? Because essentially we have 16 observations minus 1. So that should give us our 15. To get our sum of squares and our mean squared value, we could use this ANOVA command in R, ANOVA of fit.Latin squares, and this will give us our ANOVA table. All right, so you can fill in the rest of the values. If you want to try computing this by hand, then you could check with these values here and make sure you get the same thing, and then you should be good to go. All right, determine whether there is any difference in emissions among 4 different gasoline additives while controlling for drivers and the car type. So essentially we're saying HO, right? Does tau 1 equal tau 2 equal tau 3 equal tau 4 versus HA, at least one of the tau Ks does not equal the rest. Right? And if we look at our F value here, right? Because we're focused on the treatment, the F test statistic is equal to 5, and the P value is equal to 0.0452. So we're just on the border of significance. Remember, there's nothing special about 0.05, but overall our P value is saying after controlling for driver and cars, we see that the effect of the additives, right, produces differences in emissions for those 4 types of additives while controlling for drivers and the type of car. All right, great. I put some alternative code in the notes, which I'm not going to go through in the videos, but that's just another way to start manipulating the data and looking at it. It is a little less focused and takes you step by step using equations. So if you get a chance, you can look at it. It's not required, so that's why I'm not going to include it on the video, but I have posted it on the website for you guys. All right, I hope you learned something, and I see you next time.